Hi everyone, welcome back to Pullas Academy. This is physics class for Ecet students by Kiran Kumar Adar. Today we are going to discuss part 1 video in kinematics. The blueprint of this chapter is 3 marks. We have to expect 3 questions from kinematics. Okay, na? So let us discuss about the introduction. In part 1 video we will discuss about the introduction. Okay, na? Let us discuss about the introduction. Okay, now so first we have to understand what is kinematics. Actually, in kinematics mainly we will discuss about the motion of an object without considering the cause of motion. That is about the kinematics. Actually, it is a part of mechanics. In mechanics we will discuss about the effects of forces. But here in kinematics only we will discuss about the motion of object without discussion about the cause of motion. That means here in this lesson we can't discuss about the force. Just we will discuss about the motion of an object without considering the motion of an object. That is called as kinematics. In this introduction we will discuss some important concepts here. Mainly we will discuss what is the difference between rest and motion. After that we will discuss the difference between distance and displacement, difference between speed and velocity and acceleration. We will discuss so many important parameters for motion of an object. Okay, so first we have to discuss what is the difference between rest and motion. These are the important terms in this chapter. First we have to understand what is the difference between rest and motion. Okay, first let us discuss about rest and motion. Rest and motion. Do you know the difference between rest and motion? Which body is at rest, which body is in motion? Okay, now just here rest stands actually if the position of the body does not change with respect to the any fixed point or with respect to the time, then it's said to be at rest. That means if the position of the body does not change with respect to the surroundings or with respect to the time, so then it's said to be rest. Otherwise, if it is changes, that is called as motion. In this we understood the whether a body is at rest or motion. If the position of the body changes with respect to the time or surroundings, then it's said to be in motion. In this we understood whether a body is rest or motion. Okay, na? That means it is understood by the respect point. Okay, na? With respect to the time or with respect to the any fixed point, understood the body is at rest or motion. That's the important for motion and rest. Okay, na? Right. So from the example very easily understood, when you are in motion or at rest. For example, if you are traveling in a bus, you are at rest with respect to the co-passenger, but you are in motion with respect to the surroundings. That means you are at rest, you are in motion with respect to the co-passenger, you are at rest with respect to the surroundings, you are in motion. That means the same person is in motion, is at rest. That's depending upon the respect point. Without respect point here not understood. You are in motion, you are at rest. That's depending upon the respect point. Okay, that's why this motion is not considered as a absolute. This is called as a relative. This type of functions are relatives. That's why now onwards you have to understand motion is a relative function. Okay, na? So that's why now onwards you have to understand this is called relative motion. Why it is called relative motion? It is depending upon the respect point. Without respect point we can't understand the body is at rest or motion. So that's the point here. That means you are at rest with respect to the co-passenger and you are in motion with respect to the surroundings. That means the same person is at rest, the same person is in motion. When it is changes, that is changes with respect to point. That's why it is not absolute. It is not it's depending upon the respect point. The body is at rest or motion is understood. So that's why now onwards understood motion and rest. These two terms are called as relatives. These are called as relatives. That's why you have to understand relative motion. So these are the difference between rest and motion. Have you understood? Okay, now So now we are going to discuss some more important parameters in kinematics. Mainly we will discuss in this lesson, so distance, displacement, speed, velocity, acceleration. These are the important parameters for motion in a straight line. Or here we will discuss these important parameters. That's why first we need to understand these all parameters. The next introduction point in kinematics is distance and displacement. So the first introduction point is rest and motion. Already we have discussed what is the difference between rest and motion. From the example very clearly understood. So now we are going to discuss the second introduction point, that is distance and displacement. It's very important. What is the difference between distance and displacement is very important. Okay, now we are going to discuss about the differences between distance and displacement. These are the simple easy terms, but a lot what is the difference between these two terms is very important. Now we are going to discuss these two concepts here. First I want to explain about the distance. Distance denoted by capital E. What is the distance? So from the example very easily understood. For example, this is the position A, this is the position B. Suppose one body is moving from A to B. When it is moving, it is followed a certain path. For example, when it is moving along this curve line path and reaches to position B, so this curve line path length is considered as a distance. Okay, now what is distance from the example understood? So the curve line the curve line length between these two positions is considered as a distance. The curve line path length between two positions is called as a distance. Or it is followed along this path. What is the length of this path is considered as a distance. Simply is called as a distance. D is equal length of the path. What is the definition? Length of the path traveled by the body. So length of the path traveled by the body is called as distance. In this way understood. Or right here the curve line path length between two positions is called as distance. This is about the distance. Okay now. So according to the definition, nothing but length. Distance nothing but what? Length. Okay now, in this one understood. Simply is called as length of the path is called as distance. Distance is also called as path length. According to the definition, sometimes distance is also called as path length. Don't confuse. So according to the definition, nothing but length. That's why what are the SI units here? Its SI units is length. It's nothing but length. That's why its SI unit is meter. Meter is the SI unit of length. It's denoted by small m. So one important, it does not maintains any fixed direction when it is moves along this curve line. So it does not maintains any fixed direction. Its direction changes with respect to the time. That's why it has only magnitude. There is no specified direction. That's why distance is a scalar. This is a very important point. Distance, it is a scalar. Distance is a scalar. It is not a vector. This is about the distance. Okay, so now we are going to discuss the same parameter, so that is called as displacement. Now we are going to discuss about the displacement. It's denoted by S, capital S. Okay, now displacement is a vector. That's why always indicated by one arrow. This arrow mark indicates vector quantity. Actually, based on the direction, the physical quantities are classified into two types. So one is scalar, second one is vectors. So distance is scalar, but whereas displacement is vector. That's the difference between distance and displacement. That is the most important difference between distance and displacement. What is displacement? For example, between these 2 points A and B positions, if you consider one more path, that is straight line path. This, when the body moves along this straight line path, then also it reaches to the another position B. but here it travel less distance compared to this curved line path. So this shortest straight line path is considered as a displacement. That's the difference. It is also one of the length, but compared to this is the shortest distance between these two positions. That is considered as a displacement. That means when it is moving along the straight line. Okay, now this is the straight line. Shortest distance between two positions is called displacement. Simple definition is what? The straight line shortest distance between two positions is called as displacement. Okay, now so it is also called as the shortest distance between initial and final position is called as the displacement. Okay, so that's the difference between distance and displacement. So from this example, where is understood displacement is equal, simple expression is shortest distance. That means displacement nothing but distance, but it is the shortest distance when it is moves along the straight line path length. So that is only considered as the shortest distance between two points. That's why that shortest distance is called as displacement. Okay, now in this way we have to understand distance and displacement. So difference is what? When it is moves along this straight line path, it maintains a fixed direction from A to B. It is moves in the same direction. There is no change the direction, just the position is changes in a fixed direction. So that's why the change in position of a body in a specified direction is called as displacement. This means change in the position is called as displacement. That's why it is called as displacement. According to this definition, it is nothing but distance nothing but length. That's why its SI unit is also what? Its SI unit is length. Length unit is meter. That's why its SI unit also meter. But what is the difference here? It is a vector. That's the difference. It is a vector, whereas distance is scalar but displacement is a vector. That's the difference between distance and displacement. Okay, now in this way understood the difference between distance and displacement. So what are the important differences between distance and displacement? Simple differences, listen to me. One is the curved line length between two positions is called distance. The straight line path length is called as displacement. The curved line path length is called distance. That's the difference. Okay, now next, distance is a scalar, displacement is a vector. So distance is a scalar, displacement is a vector. That is one more point. And one more important point, distance always measures positively because it is a scalar. There is no direction. In any direction measure, there is no specified direction. That's why always measures positively. But whereas displacement is vector, it has fixed direction. That's why displacement may be positive, displacement may be negative, displacement may be zero. So that's the difference between distance and displacement. So one more very important point, what is the relation between distance and displacement? Always distance is greater than or equal to displacement is a correct relation. Okay, now that means distance may be greater than displacement. Distance may be equal to displacement, but distance less than displacement is impossible. There is no possible distance less than displacement. Distance is greater than displacement is possible. Distance is equal to displacement is possible, but distance less than displacement is impossible. Correct relation is distance greater than or equal displacement. When distance is equal to displacement, if the body moving along this straight line path, distance displacements are same. Okay, now when it is moves along this curved line, distance is greater than displacement. That's the difference here. It is moves along this curved line path, distance is similar to the length of this curved line, but distance always the shortest length between these 2 points. That's why distance is greater than displacement. Otherwise body is moving from A to B along this straight line, distance is equal displacement. In this way understood the distance and displacement. This is about the distance and displacement. I hope you understood what is the difference between distance and displacement. The next introduction point is difference between speed and velocity. First we are going to discuss about the speed. What is speed here? Just generally, speed is equal to distance by time. Simple definition is distance by time called as speed. This is a simple expression for speed. Okay now? So speed is equal to distance by time. So distance is equal what? From this expression in terms of speed, distance is equal speed into time. Sometimes asking distance in terms of speed, use this relation. This is the expression for distance in terms of speed. Okay, now this is the expression for speed in terms of distance. These are the important expressions for speed. So from this expression, what are the SI units here? Its SI unit is similar to units of distance meter, units of time is second. Meter for second is the SI unit of speed. So distance is scalar, time is scalar. That's why speed is a scalar. It is a scalar. This is about the speed. Whereas velocity, what is the difference between is very simple here. Velocity is a vector, speed is a scalar. That's the difference. Okay now, that means velocity v bar is equal, simple expression is displacement by time. Displacement by time stands the velocity. Distance by time stands speed. Displacement by time stands the velocity. That's the difference. We know the difference between distance and displacement. That's why understood what is the difference between speed and velocity. Here also its SI unit is what? Again meter per second, because displacement nothing but distance. That's why units is same. So but what is the difference here? It is a vector. It is a vector. That's the difference. That means speed is scalar, velocity is vector. That means speed always measures positively, but velocity may be positive, may be negative, may be zero. And one more important relation, speed is always greater than or equal velocity. V is the speed, V bar is the velocity. Because it is vector, it is scalar. That's why it is a simple difference in this indication. This is velocity, this is speed. That means speed may be greater than velocity, speed may be equal to velocity, but speed does not less than velocity. That's the relation. This is about the relation between speed and velocity. And one more introduction point here, that is average speed. Average speed and average velocity. The next introduction point is average speed and average velocity. So these expressions are important, asking simple questions. Sometimes distance is asking in terms of speed and time. Sometimes distance time is given, speed is asking. Displacement is asking, velocity time is given. Displacement is equal velocity into time. So these are the different expressions. What is the difference between average speed and average velocity is also similar. Average speed stands actually in a given time. The speed is called as average speed. In a total given time, the speed is considered as average speed. That is, simple definition is total distance. What is the definition? Here, total distance by total time. Expression is total distance by total time stands the average speed. Units, everything is similar to the speed units. It is a scalar. There is no difference. Just the total distance compared to the total time, you get the ratio. That ratio is average speed. Okay now, Next, in the same way, average velocity, it's also similar, just in terms of displacement you get it. Average velocity is equal to, according to the definition, total displacement. What is the formula here? Total displacement by total time. This is called as average velocity. Okay, now it is similar to velocity in a given total time, that is average velocity. That's the difference between average speed and average velocity. Okay, now here for average speed and average velocity we have to use some expressions, important expressions. Listen to me. For example, this is a total distance. This is a special case on average speed and average velocity. In this total displacement is S here. In this total displacement, half of the distance is travels with V1 speed. Remaining half of the distance travels with V2 speed. What is average speed? Here the formula, we have to use this formula. Listen to me, this is very important expression, that is 2V1 V2 by V1 plus V2. Okay, now what is the formula? Half of the distance with V1 speed, remaining half of the distance with V2 speed. Average speed formula 2V1 V2 by V1 plus V2. Otherwise, in this total distance, first 1/3 distance with V1 speed, second 1/3 distance with V2 speed, third 1/3 distance with V3 speed. What is average speed? Sometimes asking this question also. Here the formula is 3V1 V2 V3 by V1 V2 plus V2 V3 plus V3 V1 is the formula. Okay, now these are the special cases on average speed and average velocity. One more special case here, sometimes asking like this here. Okay, now one more special case. For example, in a total time, in a t seconds time, it travel from this point to this point. So in the half of the time it travels with V1 speed. In the remaining half of the time travels with V2 speed. What is average speed? In this case, average speed formula V1 plus V2 by 2. Okay, now t by 3 seconds V1, t by 3 is V2, t by 3 is V3, then you get V1 plus V2 plus V3 by 3. So these all are the special cases of average speed. Actually, this is a standard formula. So these are the special cases. Half of the distance with V1, half of the distance V2, use this formula. First 1/3 V1, second 1/3 V2, third 1/3 V3, use this formula. Otherwise, half of the time with V1, remaining half of the time V2, use this formula. These all are the special cases of average speed and average velocity. One more introduction point here, instantaneous speed and velocity. Instantaneous velocity. What is the difference here? At a particular given time, the speed is instantaneous. At a particular time, velocity is instantaneous. It's a small difference. In a total given time, that is average. At a particular given time, that is instantaneous speed. There is no difference. Just average instantaneous speed is, the expression is, we have to indicate a dd by dt. This is the formula. Mathematically differentiate the distance with respect to the time, you get instantaneous speed. In the same way, instantaneous velocity v bar is equal ds bar by dt. This is the formula. This expression is differentiate the displacement with respect to the time, you get it. What is differentiation? Sometimes asking differentiation. That means displacement is given in terms of time. You have to differentiate. Differentiate means decreasing the order of the function. That is called differentiate. For example, x power n is one function. If you this d by dt stands differentiation symbol. If you differentiate, it changes, x power n changes n into x power n minus 1 is the formula. Use the formula, differentiate, you get it. Suppose velocity, if you want instantaneous velocity, so given in terms of time, then differentiate that function with respect to the time, you get it here. So here differentiate with respect to the x, you get it. For example, t power n, d by dt of t power n, that's also changes n into t power n minus 1. So this is called as a differentiational model. Sometimes asking on differentiational model. In the problematic, I want to explain the differentiational model, how to find out. This formula is important. If you know this formula, you get. For instantaneous velocity and instantaneous speed, we have to follow the differentiational method. So these are some important introduction points, and one more introduction point we have. Now we are going to discuss one more introduction point, that is acceleration. What is acceleration? Listen to me. If an object is in non-uniform motion, we define acceleration. So do you know the difference between uniform and non-uniform motion? Uniform motion stands if the body covers equal distances in equal intervals of time, that is uniform motion. If it does not covers equal distances in equal intervals of time, that is non-uniform motion. So if it is non-uniform motion, the speed or velocity of the body changes with time. So that's why when its velocity changes with time, we need to define one more parameter, that is acceleration. So according to the definition, acceleration is equal to, simple expression is change in velocity. So change in velocity by time. So this expression stands the acceleration. So change in velocity means initial velocity is u, final velocity is v, then v minus u by t is the formula for acceleration. So this is an important expression for acceleration. Here u stands initial velocity. So initial velocity, because velocity changes with the time, we have to, we also velocity, but it is a final velocity. That means after taking some time, the velocity of the body is final velocity. This is the expression for acceleration. We will discuss clearly acceleration, okay, in our next videos also. Okay, here from this expression, what are the SI units of acceleration? Its SI unit is velocity unit by time. Velocity is meter per second, by second is meter per second square, is a unit of acceleration. But it is a scalar, not a scalar, it is a vector. This is very important. Acceleration is a vector. Vector means it has both magnitude and direction. Okay, now these all are the some important parameters for motion. So these all are the introduction points of kinematics. Okay, now we are going to discuss some previous Ecet model questions related to this topic. So one question is the numerical ratio of displacement to distance. Okay, now always less than 1, always greater than 1, always equal to 1, maybe less than 1 or equal to 1. Actually here relation is distance greater than or equal displacement. So that means here, so distance is greater than or equal, distance means displacement less than or equal to distance. That means from this equation, displacement by distance less than or equal 1. So this is a ratio. Here asking ratio of displacement to distance is less than or equal 1. That means it is sometimes equal to 1, sometimes less than 1. That's why maybe less than 1 or equal to 1. So from this relation understood here, this is the correct. What is the fourth option is the correct. Next one more question here. A body is moving along the circumference of a circle of radius r and it completes half of the revolution, then the ratio of its displacement to distance. So that means this is a circumference of circle, its radius is r, it completes half of the revolution, means suppose starts from A and it reaches to B point. So this semicircle is considered as the half of the revolution. When it completes half of the revolution, what is distance here? Distance is similar to the circumference of the semicircle. So that circumference of semicircle is pi r. Total circumference of circle is 2 pi r. Half of the circle is pi r. What is displacement? Straight line. Straight line path is similar to the. This is similar to diameter. This is displacement. This is distance. What is asking here? Ratio of displacement to distance. That means S by D is asking. That is 2r by pi r. So pi r cancel. 2 by pi stands 2 is to pi. Third option is correct. That's a simple question. Okay. Next, one more question here. This is if a body covers first half of its journey with v1 speed and the second half of the distance with v2 speed, then average speed. All a direct question I explain. So this is a formula 2v1 v2 by v1 plus v2. Half of the distance with v2, remaining half of the distance with v2. So the formula is 2v1 v2 by v1 plus v2. Its similar formula is sometimes given like this: 2 by v average is equal. The formula is 1 by v1 plus 1 by. If given this option, it is also correct here. It's if you simplify this equation, you get it. So these are the some previous Ecet model question related to this introduction topic. In the next video, we will discuss the next concepts in the lesson.